All right, so we're in 2-4, difference of two squares. This is going to be a factoring shortcut. Let's take a moment to disappear back into Unit 1 where we learned how to factor quadratics. As we move into factoring polynomials, we'll need to use the quadratic factoring to complete our process. One trick in factoring deals with subtracting one perfect square from another perfect square. All right. The trick here is that a squared minus b squared is going to be equal to a minus b multiplied by a plus b. So in example number 1, we've got 25x squared minus 49. 25x squared is a squared, and 49 is b squared, which means that a is equal to 5x and b is equal to 7. Because the square root of 25x squared is 5x, and the square root of 49 is 7. That being said, now that we know a and now that we know b, we can simply just put it into our equation here, and we can say that 5x minus 7 multiplied by 5x plus 7 is equal to 25x squared minus 49, so this is our answer. In the practice, you do much the same thing. In this case, a squared is 16x squared, which means that a is 4x. And then 81 is b squared, which means that b is 9. So we can say that this is the same thing as writing 4x, all of that squared, minus 9 squared. Here's our a value, here's our b value. So we've got 4x minus 9 multiplied by 4x plus 9. That's the difference of two squares. This is that simple every single time you do it. If you can figure out your a value and your b value, then just plugging it into the formula gives you your answer. So what about the sum of two squares? Well, the sum of two squares is probably the easiest thing you'll come across, mostly because if you see that this is a perfect square, this would be 13x, all of that squared, plus 121, square root of 121 is 11. So we've got plus 11 squared. Anytime you see that you have two perfect squares added together, this does not factor. And you can stop here. So this is super simple. All right. Thank you.